Hey there, Bryan Bischof, and welcome to the show.
Thanks. Glad to be here. Many-time listener, couple-time spontaneous guest.
Well, yeah. So you were a spontaneous guest in a live stream we did with Hamill about Evals, about a lot of what now like trad Evals, and we're going further down, like next level Evals today, among other things. You also joined a live stream we did. It was like a 4-hour live stream with yourself, Hamill, Shreya, Shankar, Jason Liu, Eugene Yan, Charles Fry, about what you'd seen and worked on in the first year of building with AI. That I'll link to in the show notes, actually, because it's all still so super relevant. But it's great to have you as just us chatting for an hour or an hour and a half.
Totally. Yeah, excited to be here.
I'd love to welcome everyone who's watching live. Welcome to Vanishing Gradients, our live stream with Bryan Bischof today. Just a bit of bookkeeping. All the Q&A will happen in Discord. The link is in the description and in the chat. That's just so we can continue it afterwards. Also, check out our Luma calendar in the description. We have a whole bunch of workshops and live podcasts like this. You'll dig this, Bryan. We've got an upcoming workshop with Ivan Leo, who just left Manus last week, on build your own OpenClaw. So it's really build your own personal assistant, but it's so much fun building out that workshop with him as well.
Sounds
and
like
what
it's
a time!
Be super fun. Ivan's great and like super interesting topic. I'll probably tune in for that one.
Amazing. And actually, going down the rabbit hole completely now, too early. But one thing I've really been thinking through is, we want to help people who are non-technical as well think about how to use agents. But there's some cognitive dissonance in when building a general purpose AI assistant or agent. As it turns out, building a coding agent is really the firm foundation and base you need, right?
Yeah, I mean, coding agents are incredibly powerful. It is a language that the models speak well. And it turns out, and this may come as a surprise to you, you can do a lot of things on your computer if you can write computer code. Turns out programming is actually quite powerful. Who would have thunk? Exactly.
And even just having, Pi, for example, having like a read, write, bash tool and something else, right? Incredibly powerful. But I'm getting ahead of ourselves. Please do, if you like these types of things, the obligatory, please do like and subscribe. And the best way to support the work we do is to share with a friend who you think might be interested. Do not share with someone who you think won't like it. That would be silly.
Or maybe an enemy.
Exactly.
If you have any enemies, you could share with them too.
Yeah. Tell them to learn.
Yeah. If you don't like it, your enemy might. You could kind of try to play that game. So
we are here today to talk, among other things, about the hunt for a trustworthy data agent. I just want to say a few things by way of introduction. Bryan has a background, one of the only people I know in our space, actually the only person I know in our space who has a background in non-commutative algebraic geometry like myself, and we discovered that when prepping for our 4-hour live stream a couple of years ago. He worked at IBM on time series, at Blue Bottle Coffee, started the data team there, BizOps optimization, recommender systems, then at Stitch Fix on logistics, optimization, Rexis, then moved to Weights and Biases, started the team there, analytics, ML, Hex, also started the team, built out and worked on Hex Magic. So a lot of wonderful future thinking with respect to data tooling as well. In some ways, most excitedly after this trajectory, now you're at Theory Ventures, Bryan, where you've started the team, but with a really forward-thinking team about how to invest, what to invest in, but also how to use and create modern and future data agentic tooling in pursuit of, well, let me be very clear. We've talked about this a bit, but thinking about portfolios and doing the type of research you need to do seems like an incredible open space for venture in terms of automating a bunch of really challenging things that happen there. So I'm wondering, maybe we could start by you telling us a bit about agents, the idea behind the hackathon, and how it relates to what you're up to at Theory.
Yeah, sure. So I'll start with just a little bit about Theory Ventures. So Theory Ventures is an early stage VC. We mostly invest in seed and Series A. We have around a $400 million fund. We're in fund 2. We have a small team. There's 3 investors, and there's, believe it or not, 5 people in the engineering team. And so sometimes people say like, oh, you're an investor now. And I say, no, not an investor. I am our internal sort of like head of technology and AI. And that means that like I lead a team of dedicated software engineers and AI engineers to build software to make us more successful. And so as Hugo alluded to, when you're trying to decide on what to invest in, there's a couple things that you could do. One, you could just figure out who's like got a lot of followers on Twitter. 2, you could sort of look at people that have had success in the past. 3, you could try to understand sort of like what they're building and what the opportunity is that in the market. And then 4, you could sort of like try really hard to understand like what problems are out there and how does technology potentially fit in and what has changed recently about technology that might make some of those problems more tractable. And Theory, our investment strategy is that we sort of like go very deep. We do a ton of research. We sort of come up with our own theories about how the world works. And then we go and we find companies that we think like make sense with respect to those theses. And so believe it or not, our investors are not like, riding around in helicopters trying to meet like fancy people. They're mostly like sort of behaving like academics where they're deeply researching areas and technology and then saying like, honestly, we really need a company in this particular area. Let's go figure out who is doing this or could do this, and then let's make them successful. And then the last thing I'll add is we're a very like concentrated strategy. So we're not sort of casting lots and lots and lots of bets out there. We're really investing in ones that we have extremely high conviction in, and we only make about 12 to 15 investments per fund. So that's a lot to say about sort of like theory. But why this is relevant to what we're talking about is, I've spent my entire career in data. I've worked all over the stack, sort of had every job title out there in the data world. And I've been very interested in the emergence of like ML. When ML was becoming more and more relevant for analytics, I thought it was really interesting. We could do auto ML. I built my own auto ML library a long time ago as sort of like out of curiosity because I got tired of trying the same 5 models on everything. Later on, there were some really great products in the auto ML space, but I've sort of had this very open idea to how much can ML teach us how to do things like analytics. And so a little bit of a long explanation, but long story short, I ended up working at Hex where we built a sort of like AI powered data scientist. It allowed you to sort of have all the amazing experience about notebooks. By the way, I'm a notebook obsessive. Always have found the notebook to be the best place to do coding stuff. And so we built sort of like the first AI powered notebook experience. And it was really great. We had, thousands of customers and, millions in revenue and a lot of success building that out. We broke through a lot of things early. So had, agents in production in 2023, had RAG and Graph RAG even earlier than that. I had a context engineering team in the beginning of 2024 before that was a term. We called it context construction. So if I'm being very honest, the name of the team was context construction. And that was everything from sort of like RAG tuning to whatever. I've done multi context embeddings and stuff like that. Anyway, long story short, I'm really, really curious about how these two things fit together, analytics and data science and AI. And so one of the things after coming to Theory that I thought was interesting is we have 2 portfolio companies that are doing really amazing things in the data intersect AI world. Those are MotherDuck and Omni. And because they're doing such interesting things, I found myself wondering, okay, like, have we arrived at the place where data science is kind of like over? And so one of the things I was really curious about is like, what's the difference between sort of like what Twitter is rambling on about and saying every week and LinkedIn to an even more extreme extent and what I'm seeing firsthand. And what I was seeing firsthand is that like agents were still kind of mid at data problems. And so lo and behold, I decided, let's do a hackathon. And so to wit, I worked with Hummel to host something called America's Next Top Modeler. And it was a sort of live in-person event where you came and were given a bunch of data questions like you might see in a real job. and your job was to use AI to work through those questions. Technically, you weren't required to use AI. You weren't required to do anything special. It was more just like get to the answer. But we thought the questions were probably too hard to get through a lot of them in sort of like without AI. And also it's, the sign of the times, like who wouldn't want to use AI, even if it's just going to make you faster, do whatever you want. I don't really mind. But, just to kind of like keep the spirits high, we brought in a human baseline, as we called him. And this was this really great data scientist. He had a long career of being sort of like, principal and head of data science at some like, top companies. And we brought him in and we said, okay, you're the only one that's not allowed to use AI. Good luck. And so that was the premise. And so we had about 6 hours total to see how many questions people could answer. And we just turned them loose.
Amazing. And so I've linked to the GitHub repository and to your blog post, The Hunt for a Trustworthy Data Agent, in Discord. And just remember, if you have any questions, ask them in Discord. We get to ask Bryan as many questions as we want now, so please do jump in. I'd love to know a bit about the structure of it, how you ran it, and what the challenge was. I will say that I'll set the seed, so to speak, by saying there's a training phase where people receive data and 10 example questions with solutions. And what I did yesterday or the day before was jumped into those questions and essentially just used Claude Code with a prompt that I came up with Claude when looking at the repository. And I think it was able to get 4 out of 10 or 5 out of 10 with the first prompt I did, which isn't great. It isn't necessarily horrible though, depending. The other thing I will say, I did the ones that got wrong. One was, I'll need to check which ones they were. One was with respect to lost revenue, what product resulted in lost revenue or something like that. Claude couldn't even immediately verify the correct answer after the fact as well. I was using Opus 4.5 for what that's worth, because Opus 4.6 has chewed so many tokens for me in the past.
It's so expensive.
Dude, it's wild. It's absolutely wild. I
spent like $400 on Friday on like a not super hard ticket. I just like wasn't paying super close attention, and I was like, I'll just use the model that I'm like defaulting to right now. I was like, oops.
Yeah.
So yeah.
But I suppose the other part of this is I suppose something I'm hinting towards is I didn't like build a crazy harness or anything to start. Like, Claude Code has a pretty good harness. I don't know if it's that great at these types of questions, but I suppose maybe that's an entry into thinking about, what the structure of it was and how people thought about building.
Absolutely. So we started planning this in 2025 in around maybe June, maybe July. And our priors were, everybody's talking about context engineering a lot. Like, people are really, really excited about context engineering. What we should do is we should build this like harness that people would use the harness and they would just do the context engineering, and we would see what's the best way to do context engineering. Well, by the time this
would you actually just mind quick, because we're clarifying the terms context engineering and harness as well, because we've mentioned both.
So there was this idea that, like, if you want to build great agents, what you really need to do is you need to be really, really clever about the way that the agent has access to information. So, you give the agent the ability to run like, a grep or a fancier grep over a bunch of files. Okay, so you need to put a bunch of files around so it can use those files. And you want to give it some skills and tools. Skills were not really released yet, but like, we had the sort of like makings of tools, and we had already knew that you could get
text files were released. Let's be very
exactly. We had these ideas that like Claude Code was actually really powerful, and people were starting to see the vision there. They were starting to do custom things where you're like, how can I make Claude Code perform even better by doing some pre-work or building some, specific workflows that Claude Code could use to learn more about things. And so everyone was really excited about context engineering and like talking about it a lot. And it's just this concept of how do you get all the information available to the agent so that the agent, maybe through MCP or maybe through other mechanisms, that the agent can kind of reach out and get the information it needs to be able to accomplish the task. Can you give it a sort of like sandbox to run code in? Can you, give it more and more of these like pre-built workflows, whatever you want to do. Maybe it is a RAG system. Maybe it's not a RAG system. We can argue with that. But long story short, people had all these different ideas of like, this is what makes a great agent. And I found myself hearing almost like on a weekly basis, like I've got the secret sauce to building agents. And this week it's DSPy. And next week it's like my cursor rules are like, like a family of employees and they all have names. And the week after that, it's some like more complicated sort of, I remember JEPA was really, really popular for a hot minute. Like just everybody had their own thing. And so my thinking was, okay, I'll build this like uniform harness. And what I'll do is I'll just say, you can do anything you want to do on context engineering, and we're going to give it to the same harness, and we're going to see what it gets right. And so as soon as I decided to do that, I thought, okay, what I need a really good way to eval. I can't spend the entire hackathon manually looking at people's responses and saying, this is right, this is like kind of right, it would be impossible. We couldn't scale. We could hire like 25 TAs, and maybe that would have done it, but it would have been a giant pain in the ass. So I was like, what if we kind of also play to my other strong belief, which is evaluation should be more binary or a set of binary questions than people like to make it out to be. People often overthink and they're like, oh, it's like too hard to measure. I better make 18 judges in the council. And so long story short, I was like, okay, I'm going to make what are called like staged evals, or you can call them checkpoint evals. In some papers, they call it that. I personally have always called this like a failure funnel. And so it's basically this like this funnel of things where if you get this right, then you can possibly get to the next step, et cetera, et cetera. Long story short.
And just on that step,
yeah.
Can you just tell us, can we just go slightly deeper into failure as a funnel and transition matrices and how they can actually help with evaluation when we're moving to multi-hop, multi-step agentic systems?
Totally. If I ask you, Hugo, I'd really like you to explain to me like my PhD thesis in a single paragraph. Go ahead.
All right. Well, actually, I don't remember. I know it was about non-commutative algebraic geometry, which essentially is about the relations between geometric structures and algebraic structures and finding relationships between them, essentially as categories, right? So we go into category theory. I don't know much more about what you did. I presume cohomology was involved. I wouldn't be surprised whether we generalized to Grothendieck topologies of some sort, looked at schemes as well, and I wouldn't be shocked if, I mean, this is bordering on like poetry as opposed to a description, but you did it in Berkeley, so let's go Ginsberg. I wouldn't be surprised if there were spectral sequences involved somewhere at some point.
Okay. So like, just to be clear, I
apologize,
on the spot.
everyone.
He had no expectation that I was going to ask him this question. This is a very hard question. So kudos and thanks for playing ball. But let's evaluate it like we would evaluate an LLM. He's spitting out some next token predictions, and let's see how well he did. So if I wanted to evaluate that, I could just say like, how good is it, or how accurate was it, or do I feel like it really captured the main idea? But I could also evaluate it in a little bit more of a like series of binary questions. So one, did he like call out that it was like a math PhD? I mean, he didn't explicitly say it, but it was very clear that he like made that evident. And so like, I would say that at least this response from this language model, which we're going to call Hugo a language model for now, this language model succeeded at like identifying that it was like a math PhD. Okay, that's fine. He also mentioned that the subdomain was in category theory. I think that's, if you don't notice that it's like a math PhD, you'll never ask the question, was it in category theory? And so you can see why there's like a causal relationship here. Don't even bother to ask the question, did he identify that it was NCAG? If he didn't already identify that it was math, but he did identify as math, so let's ask the follow-up question. That's great. He talked about category theory. Actually, that's probably the next thing that you'd want to ask is like, did they mention category theory? Because categories are really important to the work that I did. So that would also be like another step in this causal chain. You shouldn't really ask this question of like, did they talk about category theory unless they already said like NCAG, because category theory is really, really broad. And so it's only interesting to ask, did he catch that? If he's already identified sort of the world. And you can keep going. You can say, oh, we talked about schemes. That's another thing that's like really important to the work that I did. And so like clearly we're like getting closer and closer to this is a reasonable explanation. Now, this is not assessing the quality of the explanation or things like that. It's really just asking, is this an explanation that we can even bother using, or should we like hard exit out and basically say, oh no, like he's so far off the mark, we need to like really have a conversation, me and Hugo, about what on earth I did. Now, candidly, Hugo didn't talk about sort of I would say the fundamental idea, which is it's related to representation theory. That's okay. That might be like the fifth thing that we want to assess in this failure funnel of how good did Hugo do, like touching on the main ideas. He did talk about the relationship between geometry and algebra. That's another one that's a great thing to call out about my personal thesis work. We can stop talking about my thesis, but the thing that I want to call out here is even this very open-ended thing of like, describe my thesis. We're able to turn that into a bunch of binary questions. Is he getting closer and closer to a great answer? You may at the end want to do something that feels a little bit more vibesy. You may at the end want to do something that's a little bit harder to assess, but there's so much value in this assessment that we've already done. We already now have identified that Hugo has a pretty good understanding of the kinds of things I thought about in my work. It may not be the case that he understands sort of like the main result that I proved, but he's got a pretty good understanding. What that means is if Hugo bumps into somebody randomly and talks about me and my thesis, I'm going to feel okay. Like I'm not like super scandalized. Whereas if instead he was like, well, he worked on like particle physics, I'd be like, okay, let's take a bit of a step back. It's like very tangentially related. So that's the kind of idea of like taking this like really open-ended thing and making it precise. Why is this?
I love it. Because, and also,
yeah,
I was just going to say, to be clear, the work we did makes particle physics trivial. I mean, it's a corollary to everything we were working on.
Right.
And on top of that, for anyone who's a bit mathy but hasn't checked out representation theory, hands down one of the most beautiful things you can encounter in the wild world of mathematics.
Yeah, love representation theory. Some of us are matrix enjoyers from a long time ago.
And you can see I've brought up your example in one of Hamel's blog posts, which I've linked to in Discord as well.
Absolutely. So what you're looking at here is you're looking at what I consider to be sort of like how you evaluate that thing that we just talked about. We just talked about a failure funnel. And so at each of the stages, you want to ask how many of your sort of generations pass these different sort of questions. And so if we were to be evaluating some capability and we would be to build a failure funnel or a series of questions that the better and better, the further and further you get into that funnel, the better and better you're doing. What you're doing is you're actually building up a sort of estimator for how strong your capability is with respect to a specific set of questions. Once you've done that, what you're allowed to do is you're allowed to ask sort of where do we need to focus? In the sort of worst case, you'll have lots of problems early on. They don't even pass this first evaluation. And so you've got a lot of work to do. Maybe some of them are spread out and some of them get all the way to sort of like the last set of questions. There's just less work to do. You should think of this as big versus small. Big, important things that you never want to fail at come first. Little, small things that like, it'd be great if it didn't fail at come later. So this is the way that I often think about sort of checkpointed evals. And then the sort of transition matrix that Hugo mentioned is as you make changes to your system, how many of your individual examples that you're evaluating transition from failing at one stage to failing at a later stage or sometimes an earlier stage. This is a really powerful technique when you're rapidly evaluating new models or new sort of context or new systems that you're integrating. This just makes it a whole hell of a lot easier than asking the question, is it better? I don't know. Like there's too many ways to be better or worse. When people ask me, is Claude 4.6 any better than 4.5? It feels better, but like I'd like to know on some evals. And so I have some evals. Long story short, that is a transition matrix. That is a sort of like checkpointed eval system. And what I wanted to do is I wanted to build one of those for a bunch of data questions so that when people submitted the answers, I could tell them A, where they were getting things wrong, and B, if they were getting any closer.
Super cool. And I am just interested in the example that we brought up. I think one of the columns and rows was was the correct tool called, then were the correct arguments or passed or that type of stuff. In that case, it presumes that there is, I mean, if the agent were to do it a different way, there are different paths to get to the correct answer. So how do you think about creating these evals when you have systems like this?
Absolutely. I think the question in everybody's mind is like, agents are getting better. We should let like the agent be more sort of like in control of what it does. We should give less precise instructions. And we have seen a lot of systems that used to need really precise instructions and systems transitioning to things that have a lot more freedom. In my opinion, it's always been a sort of sizing question. How do you want to evaluate your system? And what are the things that you feel like you really, really need to evaluate? I don't think that I need to evaluate what code it chooses to run to figure out sort of like if the server is running. Who cares? All I really care about is if the server is not running, it can detect that. If the server is running, it can detect that. I'm assuming you're working with a coding agent that needs to run the server to like test something. Ultimately, yes, we are moving to a world where there's like chunkier and chunkier things that you can like trust to the agent. But ultimately, there are still little checkpoints that you want to observe and you want to feel confident that your system gets those things right. A lot of people talk about sort of like, oh, are you using skills? And it's like, yeah, I'm using some skills here and there. And so like, okay, a skill is an atomic unit of workflow. It's a thing that like I've previously determined how I want this to work. I've made it a skill for a reason. If you believe that skills are useful, well, then you believe that there's like some useful checkpointing. It's a great place to put a little, eval. If you don't believe skills are useful, okay, I assume that you're sort of like always running everything net new. And I would ask you then sort of like, well, why? Why not like codify certain things that like you kind of want to be reproducible? MCP and tools and skills and even like cursor rules. These are all examples on a theme. And the theme is simply, I want to codify a certain behavior and make sure that it's like kind of reproducible. That's just an eval. And so that's a great place to put a checkpoint.
Awesome. So now I'd love to dive into the hackathon and competition itself, and for lack of a better term, like the phenomenology of the experience. Like what happens when you get in there?
Yeah. So one thing I'll say is we had about 150 people come in person to sort of play this game. Hugo alluded to the fact before that I gave them like a training period of time. My thinking was I can give them just a bunch of questions and I know the answers and I can tell them when they get them right or wrong. But one thing that might help people get started and give them the highest likelihood of having fun is to give them the answers for some to kind of like get warmed up. I wanted them to be able to say, is my system working? Is something completely off the rails? And so what I did is I give them answers to a small number of questions. I think it was around 15 at the beginning so that they could check. They could say, am I even on the right path? And the reason that's so valuable is they're able to sit in that loop, sit in that feedback loop. They're able to get that back pressure from the system on whether or not sort of their agent is doing things that are useful. Now, remember, these are real data science questions. These are data science questions that feel like something that you might actually have to do in your like normal job as a data scientist. I purposely wanted to go out of my way to make questions that I felt were representative of real data questions. I often see what I would consider to be bullshit evals, especially in data, which is like, write this dumb SQL. Almost every one of these like dumb SQL questions that I've seen for benchmarks are just so either obviously easy or overwhelmingly like kind of like adversarial. They don't feel valuable as a data scientist. It's something that you probably would never ask a real data scientist to do. So I went out of my way to create real ones. Let me read one to you.
I'd love that.
Let me, here we go. I'm just pulling it up on a different screen real fast. Sorry about that.
No worries.
Okay.
I'm on the edge of my seat.
So one question that I asked, this was during the sort of period where I gave the answers. Identify the item with the strongest seasonal sales pattern, where 3 consecutive calendar months account for the highest percentage of its annual sales. Report the item SKU and the percentage of annual sales that these 3 peak months represent. Let's like think about this for a second. So first,
Also, could you just describe a bit about the data set, perhaps, as well?
Let me come back to that in a second.
Yeah.
Because I think there's a lot to say there. So I say identify the item with the strongest seasonal sales pattern. Okay, so this is a very reasonable thing. I've done this job, like this is like out of job before, where the 3 consecutive calendar months account for the highest percentage of its annual sales. So ultimately, I'm giving them a definition of seasonality.
Yeah.
This is one where it's very similar to real world, but it's a little bit easier than real world. One of the things that I was trying really hard when crafting these questions is to make them have one and only one correct answer. If I just say strongest seasonal sales pattern, you can interpret it in a lot of different ways. Maybe your organization interprets seasonal sales pattern in a very unique way. This is one of the difficulties of being a data scientist, is getting people clear on definitions. So I needed to do something to push back on that challenge. And so what I did is I inserted words like where 3 consecutive calendar months account for the highest percentage of its annual sales. So what that means is sort of like, more than 50% of the sales are in 3 months. That's what I mean by seasonal sales pattern. And I'm giving them the definition in line. But you'll notice I don't explicitly have an equation. I don't explicitly have a thing where I call out and say, this is the definition of seasonal. I just say it in a natural language kind of way, a way that a human could interpret. A language model may struggle. Report the item SKU and the percentage of annual sales that these 3 peak months represent. Notice I'm giving them a very explicit thing that I'm looking for. This is the other piece of the puzzle in crafting these questions. I need to be incredibly precise about what they need to turn in. Why? Because everything is going to be auto-graded. They're going to turn in basically an Excel file, CSV technically, and I'm going to evaluate that CSV automatically. This allows us to give them feedback without revealing the answers or without having humans that are going to have to constantly decompose what they got wrong. What I don't need is I don't need to see their agent trace. I don't need to see how they got to the answer. I don't even need to see sort of like, what data they used. But it's still, coming back to the thing we talked about before, it's still a sort of benchmark. It's a like milestones towards the correct answer. They're checkpointed. What are the checkpoints? The item SKU. Did they find the right item? What are the peak months? Did they find the right months? And the percentage. Did they calculate the percentage correctly? This one's a little bit of like a simpler example of these checkpoints. Some of the checkpoints are a little bit, they can help you kind of get there. And so this can tell you, did you get the right item, but just screw up the way that you were calculating, et cetera, et cetera. And so that's the way that these questions are phrased. And the high level idea, sort of like the inspiration for all these questions, was how can I take a lot of the questions that I've seen in my career as a data scientist and turn them into something of this form? I wanted to capture the experience of being a data scientist and what are the things that are tricky, not impossible, not super straightforward, you just hammer it out, but the things that really eat up an afternoon or unfortunately a whole weekend.
Or like 11 p.m. to 6 a.m. on a Sunday.
Yes. And so in this example, they were there in person. They had 2 hours of training where they got to see the answers to these things and they got to see the questions and they got to see if their agents were like doing the right thing. We gave them the full data set. And so they got to sort of like immediately start working with the data set. You could spend your 2 hours preparing the data set, making it easier to work with. And there's a lot of work to do on the data set to make it easier. And so that was kind of their choice of how they wanted to use the time. Then they had basically an hour and a half, an hour and a half, an hour and a half. And that was to basically work through a set of questions and see how well they could do on the leaderboard. I purposely did these sort of like staged reveals because I wanted to control a little bit how much time they had for different sections. And I also wanted to make sure that we had sort of like, new things unveiling as they were there. And they got to trade off of like, do I keep working on things I've already seen? Do I work on new stuff? When do I sort of transition to the new set of problems? I thought it would be a little bit more fun from a game perspective.
Without a doubt. And so in the end, though, the median score, correct me if I'm wrong, was 23 out of 65. And this is, a bunch of world-class engineers. What did you expect going in? Was this surprising?
I told people before we got there, I had 2 worries. One worry was that nobody would get a single problem. And the other worry was that more than 5 people would get every single one. Those were my worries. Anything else I was fine with. I was like, I'm completely fine with any other outcome. I don't want it to be a complete disaster on either side. And so we did a lot of effort ahead of time to try to keep us out of those 2 regimes, trying to make sure there was ones that were really hard and some of the ones that were really not so bad. From my perspective, this was like a great outcome. I think it was quite difficult, but it was not, it kind of felt like, maybe not quite as hard as Putnam, but like approaching that level of like some of these questions no one's going to get. That's like for fiendishly difficult. One of the things that we, did that I think really made it especially challenging is that like the data itself came in 3 modalities. It came in like tabular data. So just like sitting in CSV files, basically, technically Parquet, but, 2, we had a bunch of JSON, like JSON-L files. And so basically these are log files. So as you probably know, when you work for a real company, some of your data lives in your data warehouse, and that's really great. And you can write queries against it and everyone's happy. And some of your data does not. Some of your data lives in log files. Why haven't you extracted those log files into the data warehouse? In some cases, you just haven't had time. In other cases, because it's not that kind of data. It's like a different kind of data altogether. And so why would we have JSON-L files and like log? Well, because actually we had systems in this fake company that were generating log files. And sometimes the answer to your question is in the log files. And as a data scientist, you hear a lot of like, oh, how hard is it to be a data scientist? You just write SQL all day. No, you don't just write SQL all day. Sometimes you're looking through fucking logs. Excuse me. I forget if you're allowed to swear on this podcast, but
you are. But YouTube downgrades the recommendations, though.
Okay.
But we're a rocket ship already, Brian. You and me. So no, not at all.
So anyway, like just the reality of being a data scientist is you're working with like different modalities of data. And to that end, I also had a third kind of data, and that was PDFs. We actually had 750,000 PDFs in our data set. And you might say, like, what? Like, why? What are those? And those are related to the business. But this is the reality. Sometimes your data is in unstructured formats. Logs are semi-structured. SQL tables are, wonderfully structured. And PDFs are unstructured. And I was like, if I really want this to feel like a real, what's it like to be a data person? Like, can we hand over the keys to the agents and say, all right, we've had lots of fun as data scientists, moving on with our lives. We're going to go out and farm. Like, are we there? Well, it had better be able to do everything. And let's just say it couldn't. So long story short, all 3 of these modalities were part of the puzzle, which means some of the questions, the answers are in the SQL database. Some of the questions, the answers are hiding in the logs. Some of the questions, the answers are hiding in the PDFs. And you might think, okay, so this is a search problem. All you're really doing is just searching. search. Not quite. Because I don't know if you've ever written code to aggregate numbers over PDFs, but it's a real pain in the ass. And actually, some of the questions required you to aggregate over the PDFs. One question that I think nobody got actually requires you to basically look at every PDF, find out if one particular like thing was on that PDF. If so, grab a number from the same PDF and add. Now,
so one thing you mentioned was extracting from logs and putting them in the database. Did anybody, or would you suggest to perhaps try to extract as much from the PDF into structured data in order to give the agent access to that instead of having it go and crawl? Because they get lazy over PDFs as well, I find. If they look at PDFs long enough, there's a lot in context, and they'll be like us. Yeah, this is the answer, bro.
Yes. And so short answer is during the hackathon, no one did pull this off, but longer answer, this is what I would recommend you do to solve this kind of problem. So there's a great project, Document Wrangler or DocETL, depending on your specific application. These are projects by Shreya Shankar. And this is like a perfect demonstration of why that like pattern for language models is so powerful. If you make a language model look at a document and extract a bunch of information, specific information, and then you have another job downstream that can like aggregate this into things, tasks like this go from basically impossible to extremely straightforward. And so one thing that you might ask, and we haven't really gotten to the sort of the punchline of the whole event yet, but like one thing you can ask is like, how good is an agent like Claude Code at just sort of like figuring that out, being able to say like, oh shit, I got to pull this information from 750,000 PDFs. I better not just look at them one by one. And so the answer is like, no, these agents, they're not that clever yet. They're not starting to think in self-orchestration. Obviously, like over the last month, we've had some breakout success of some self-orchestration with OpenClaw, but like we're still quite far from agents orchestrating intelligently other agents right now, where it's sort of like level 0, where they're like, I can ask another agent, which I've previously been told is good at doing this thing.
Awesome. And I'm so glad you mentioned Doc Wrangler and DocETL. I've linked to that project in Discord and will in the show notes. And I've actually also linked to a podcast I did with Shreya about it, and some of the wonderful work they've been doing actually in California with respect to police misconduct reports and stuff that, ingesting and transforming documents that took people like 35 years originally, and now they're able to do it with LLMs for, on the order of 10 million. So I really encourage everyone to check out that work.
Exactly.
So then at the competition, the hackathon, when you walked around, or like what were people doing? What were people trying? What were the bottlenecks? What were the failure modes? What were the successes?
So in some cases, what people were doing they were sort of asking Claude Code to solve these problems, and they were submitting them. Some people were doing a little bit of like what we were just talking about, like designing an intelligent system that their agent could make use of. Some people were using a specific tool. Like I know someone from Contextual was there, and they were able to use Contextual to do like pretty decent work. I think, one of the teams was using some sort of like combination of like manual data work with some, like agents powering them. And then some people were full on hyper engineering. They were just, I've got 8 Claude codes running, and they're all just trying to get to the answer, and I'm just nursing them. I'm just like popping in, poking. Okay. And there were some pretty nice approaches from pretty much like all of those different strategies. I think, our human baseline, he was just hammering away. Some of these problems were especially difficult for him. Obviously, looking at 750,000 PDFs is intractable, so he would have had to write some code on the fly to do that.
And he was not allowed to use AI at all, like not like code completion?
Correct. He wasn't even allowed to use ChatGPT to ask questions. So, but yeah, there was actually quite a variety of approaches. I think the thing that I was hoping for was more people in the bucket of, I've crafted a thing, And then I'm going to use that thing to see where the failure modes are. And then I'm going to improve that thing and get closer and closer. I didn't see a lot of that. What I did see do quite well was people that were using agents a lot, and they're very general purpose coding agents. And that was maybe the thing that jumped out the most, was general purpose coding agents with a lot of like poking and prodding could get a lot of shots on goal. And so they could get a lot of like potential answers. And this is one thing that like I talked about in my write-up, I kind of made a mistake. My mistake was there were no penalty for wrong answers. You could just keep submitting. Submit. It's like when if you've ever like sort of like done like an online test and it doesn't care how many times you submit, at a certain point you might get annoyed and just like hit the up button, like add 1 to the integer until it gives you the right answer. That unfortunately was allowed. And why that was a problem was there's no downside to just trying more shit. And actually agents are quite good at trying a lot of shit. And so what this reminded me, which I knew and yet failed to really like internalize, was that agents are best when you can construct a loop that pushes on that agent to kind of like get to a sort of like more successful outcome. So if you want agents to write all your code for you, okay, design a really powerful system to evaluate when that is sufficient. Not just unit tests, but really like powerful integration tests and UI tests and things that make you feel like extreme confidence. Ask yourself, what could I construct such that if it's passing that, it's fine. Move on. People like to talk these days a lot about like, do you even read the code? And it's like, well, one way that I would feel comfortable not reading the code is if we had an extremely clear definition of what's good enough. It's very similar to the checkpoints conversation that we had at the beginning of this thing. If I want to know, does Hugo summarize my PhD well enough? I don't actually need to like hear every word of his summary, candidly. What I really need to do is I need to make sure that like certain things are not completely wrong. And then I'll feel comfortable enough. And it's the same is true for, coding agents. So the thing that it reminded me that I had known and kind of like, hadn't thought enough about was these systems yield the best outcomes if the goal of the outcome is to get the right answer or to check those boxes. And so the more that you can align incentives of the thing that we require to be true is the thing that we care about, the more that you can align those incentives, the more that you're going to be building incredibly valuable products with AI. However, data science is not all about getting the right answer. And it's not likely that in most data science applications, you can get this sort of feedback loop. As an example, Hugo, if you ask me, hey, Bryan, I've got all this data on my podcast. Can you analyze my data for me? Can you tell me sort of like generally what topics I get the most listeners for? Is there any sort of like specific set of ideas that a lot of people tune in for? And also while you're at it, can you let me know like what kind of speakers people tend to stay to the end of the interview versus leaving halfway through? You can give me that question and I can say, sure, Hugo, happy to do that. I think the topic is bananas. And actually, if the speaker is wearing a yellow shirt, people tend to stay. Now that's an answer. And what do you think your reaction to that would be, Hugo?
I'd probably invite you on more often.
Fair enough.
But I'd be like, hey, that isn't what I meant by my question, actually.
Certainly. And you might even be skeptical that it's right. And if you ask me, how did you come to that conclusion? I would have to say like, oh, I just made it up. And how would you feel if my reaction was, oh, I simply made it up?
I'd appreciate your honesty, but I'd also probably not ask you any more questions.
Fair enough. What if instead of saying I made it up, what if instead I said, well, I looked at the transcript from every single interview and then I made it up? How would you feel?
I'd be impressed and concerned and think there was something very strange happening.
Okay, so I wrote in Rust a really amazing text extraction library, and I actually built an entire BI platform on top of that. And I used the BI platform and the extraction tool to create a data visualization of the number of letters in every word that was spoken in your transcripts, and then I made it up.
So now, if we're still talking about a human, I'd get out of there. But I'd probably say let's have a look at some of the earlier steps, and see what you built with an agent or an LLM. I'd do that. With a human, I just wouldn't believe anything at that point. And,
Understood. Yeah. And that last point you just made, you like wouldn't believe in it. You'd lose trust.
Yeah. Yeah.
That's the problem. When you're a data scientist, the whole career, your entire existence is based on sort of like a key principle, which is like truth seekingness. Your person who's asking you questions, the person who's giving you things to investigate or asking you to help them solve problems, they are sort of like truth seeking. They want an answer on what to do. And you as a data scientist are successful if and only if you too can be truth seeking. You may be locally successful by being a bullshitter, but you won't be globally successful by being a bullshitter. That is if you believe that there's like any opportunity for data teams to impact the business. If you don't believe that, that's fine, but you probably aren't listening to this podcast. So long story short, the reality is like agents are the supreme bullshitters. You've heard a lot about sort of sycophancy and things like that. It goes actually way deeper than just sycophancy of like, I want to make you happy. It's actually a lot more on the like, they will do things that seem very reasonable, similar to like, I made these histograms of all the letters of like the words, and it's totally unrelated to the actual question that was asked. And ultimately, all that matters is that when Hugo asked me a question like this, that he can trust the answer that I give back is a best attempt. It doesn't need to always be right. He's going to expect that sometimes I get the wrong answer. That's just par for the course. But one of the things that Hugo, as someone who might be like managing a data scientist in this example, is going to learn, and that you do learn as a great manager for data scientists, is to interrogate, but to interrogate in sort of like a curious way. And so Hugo is going to learn that when he asks me questions, that he's going to be able to ask me follow-ups and like, how did you come to that? And like, why did you take that approach? And these are all things that I, as a data scientist, learn how to communicate. None of these things are within the agent's like playbook. They are just trying to do shit to try to get to an answer and get that back to the requester. You can't interrogate them. You can't understand their theory of mind. All you can really do is sort of like see what the answer they give is, and maybe read 80 billion traces, because that's the one reality of like these agents is now the number of tokens that they shit out in the process is exceedingly large.
Yeah, and actually, to your point, Nathan Danielson, who he's an AI engineer and AI leader at Carvana, who's also in California, he's in LA though, has written in Discord that these things are, and he's been working in data science for a long time now, but he's written it, this is tough, right, since most data science and so forth is discovery driven, you can't really have a full spec up front, even with respect to what success looks like, particularly if like it's R&D type stuff. And I think you'll really like this. He says it's hard to frame the quote unquote taste of what success looks like.
I agree. And he actually also calls out another thing that I think is really interesting. One thing that we didn't get a chance to do in this benchmark, but I am interested in doing, is follow-ups. Because anyone that's been a data scientist knows that the first question is only the beginning. It is incredibly rare, vanishingly rare, if you will, that like, you ask me a data question, I give you an answer, you're like, all right, cool, thanks. Like, no, it's always like, well, now that makes me wonder this, and so on. And that's great. And that's actually one of the most fun things about being a data scientist, but it is very difficult sort of like to build that into a benchmark. But I'd love to sort of say, okay, I ask you this initial thing about seasonal sales patterns, you give me the answer, and I say, oh, that's curious. That's an item that's only sold out of like this one warehouse. Are there other questions, like other ones that are sold out of that warehouse that have a similar pattern? And so it's just very natural. It's very natural to have more questions.
So let me ask you this to play provocateur. Uh, do we even want answers to questions, or in the end, do we want decisions?
So, there has definitely been a lot of debate about sort of like decision science, data science, like what's really one thing that I've always believed about the industry of data science is that you are trying to help the organization improve. Sometimes the organization will say, we have two roads. We can go A or B. Which should we do? When you're running an A/B test, it feels very easy to say, this is a decision. That's why you sometimes hear experimentalists called decision scientists. That's fine. But that is not the lion's share of where data science can be valuable. Like asking the question sort of like, like how is our inventory matched to our customers? That's a real question that I was working on for, candidly, a year. How well is our inventory matched to our customers? It's so broad. There's so many ways. It's certainly not a decision question. It's not like, oh, decision is actually like don't buy any inventory. It's not, should we buy this item? It's not, should we buy that item? Actually, the items that we can buy, they change throughout the year. So how is this even going to be like directly related? Ultimately, when I, talk about like great data science, there's like three components, and the components are problem framing, data framing, and objective framing. And this really falls into the problem framing. When you say how well matched is our inventory to our customers, and said even more, we'll say executive, would be sort of like, does our inventory suck? That's an executive question. Problem framing is, okay, what they really mean is our inventory well matched for our customers? And second pass is the inventory that we have available, like what the customers want to buy when they want to buy it? And the next version of that question is, how frequently are customers buying less than they would because of what they have access to? And the next version is, how frequently would small changes to our inventory decisions yield better results for customer purchasing? And so on and so on and so on. And so, believe it or not, data framing is not, or sorry, like problem framing is not just I did it one time, I framed the problem. It's like, no. You keep thinking and getting closer.
It's a continuous process.
Finer. You're zooming in on this loci of like, what is a tractable question? So do I think that this is like decision science at large? No, because all of that's not decision science. What's decision science is, I have an observation. My observation is that our inventory for like petite men sucks. What's the decision? The decision is, now we have to decide, do we buy more, or do we basically just assume that it's going to continue to suck? Now that's a decision, and we can try to assess that decision with data too. We can ask the question, how much revenue do like petite men drive? How many customers do we think we're missing out on because it's bad for petite men? How can we evaluate if that's why? There's a lot of decisions to be explored, but data science is more than decision science.
I'm also interested in, I don't know if we've mentioned this. We've mentioned that the process was you go in, explore have time to explore the data. MCP servers, which I hope we will get to as well, because I know you've updated your priors on MCP. Then a bunch of questions to help you build the agent that you got the answers to. Then questions you don't have the answer to, you submit those. Then, though, close to the end, you don't run the agent yourself to submit the answers. You give it to Bryan's team, who then runs it. So you're out of the loop there.
So we did originally plan that we would require them to sort of like give us the agent and we would run the agent. But actually, we decided to scrap that part of it, and we let it be completely you do you. And the reason that we actually walked back from this, like you have to submit an agent, like a Kaggle style interaction, the main reason that we decided not to do that is because we wanted to be as open-minded as we possibly could for the ways that AI can fit into the workflow.
That was going to be my question. Yeah.
Yeah. I wanted to understand, like, what's the best place for AI to fit into the workflow? If you've got to get questions answered, like, what should you do? And in my opinion, saying that the agent is like, completely hands off and there's no human involved, it doesn't really answer that question. It's interesting. It's still a really interesting question, but I wanted this to be as pure as I possibly could make it. And I wanted to just say, if I had to employ 2 of these people out of this group to, for whatever reason, answer a shitload of questions about like this like made up data set, which ones do I think would be the most successful at getting me good answers? And that was the goal. Now, unfortunately, we did fail in our goal because of this thing I mentioned before, where you could just keep trying and trying and trying. And so we didn't get to the great answer of how do people gain confidence. The one thing that I would change if I would do this again is I would make there be a penalty for incorrect answers, because then as the submitter, you have to trust that it's right.
I'm a huge fan of costs. Having costs to things helps me, prioritize, especially with my, impulsive mind. I'm interested now in just going into a few different things that are, previously hot or hot in our space now, and that type of stuff, such as MCP and skills and subagents and these types of things, all of which I think have their places. But for clarity, I know that you went from being an MCP skeptic to a convert, perhaps.
Yeah.
What changed your mind, and why do you think MCP matters for scaling tools across orgs?
Totally. So, okay, I tried MCP pretty much as soon as it dropped. For whatever reason, it just like seemed relevant when I was sort of like working on data agents. I was like, this seems interesting. Like, I could imagine where you'd want to connect an MCP to an existing data set and maybe give it some instructions about that data set. I could see why that would be useful for data agents, not dating agents. I haven't worked on this.
Maybe for those as well. I mean, that's...
So
I might pitch you soon at you and Tomas soon about dating agents.
So I tried this pretty early, and one, the models were just not very good at using. Even Claude was just not that good at using the MCP. It would constantly like malform its request, and even though it had been trained on how to use them, it just almost never worked. And so I was kind of annoyed, and I was like, also like you have to run it locally, and so I was finding myself thinking like, okay, like how valuable is this? And I was like, I know we're getting, it's only been a month, but we're already getting like 18 billion people saying remote MCP servers is the next like SaaS company. And I was like, I don't know, like, should we build an MCP server? And at the time I was working at Hex, and I was like, should we build an MCP server? And I was like, I don't really see the value. It just doesn't seem like it's going to fit into anybody's workflow in a way that's like incredibly useful. So flash forward, we have this sort of like rise and fall of like MCP obsession where no one can shut up about it. And then, I started working at Theory, and we started talking about specific problems. And one of the specific problems was we have a bunch of proprietary data that either we've created or we're sort of like, like buying and combining with other data. And so what we want the investors to be able to work with these data. But in addition to working with these data, the investors are often using LMs as part of their workflow. So if they're going to work on some of that research that we talked about earlier, they're going to want to sort of use a language model to kind of like assist them. But they want all this proprietary data that we have to be part of this too. And so I'm like, okay, so what we can do is we can sort of like build a custom app that like, connects to these data, and then they can like write the document in the custom app, and they can have an LLM like help that. And I started getting a little bit anxious about a few different things. Like, one, how much of a custom app do we really need to build versus like using a regular chat client? Because some of the things that they're doing right now in chat clients are pretty close to what they want to do. Two, what's the right way to distribute these data to wherever they're like working with the language model? Three, are they all going to be happy with whatever product we build? Or should I continue to let them do it? Like, one person does everything in Claude Code. One person does everything in Cursor. One person does pretty much all of their work in the ChatGPT like desktop app. One person kind of switches between like, a couple different web apps and like playing here and there. And so I'm like, man, this is going to get like, one person uses the Notion AI. So I'm like, okay, this is actually like quite a disparate set of current uses. I need to field all that. And Adam, one of the AI engineers on my team, he was like, it does seem like this is kind of the point of like a remote MCP server. It's really about distribution. And for whatever reason, that's what clicked in my head. Distribution. As soon as he gave me this concept of like, it's about distribution, suddenly I went from like, the models are better at doing this in local scripts and using code execution and using other things that agents are good at, to, hold on a second, actually, MCP has a really important place. And that is the number one thing. I don't think that like first-party MCPs are the most important thing. I think that they are somewhat useful. I think the custom MCP that you build in your organization to model all of the important things about your business so that other people can work with language models and benefit from that, now that is valuable. For those of you that have been in the data space a long time, it may sound like a semantic layer. I sometimes joke that like MCPs are semantic layers for like arbitrary sets of data. You want a semantic layer that wraps around your Notion data. You can use the MCP to do that. You want a semantic layer that stitches together sort of all of your like Confluence docs and your emails and this one specific set of like Slack channels. That MCP is a semantic layer. It doesn't need to be sort of a semantic level layer in the traditional sense. It's just this definition. It's this data modeling layer that also solves distribution. And the distribution is to other language model interfaces. Basically, to say it really, really short, it reduces the amount of copy and pasta.
Without a doubt. And Nathan has also mentioned in the chat that for him, and I agree that MCP was able to rapidly mature along with tool calling accuracy as well. And it makes a lot more sense when we have that. I do want to move to thinking about subagents, because last time we spoke, and correct me if I'm paraphrasing you too broadly or specifically, but if I recall correctly, you said subagents in some ways are really just poorly defined skills and tool calls. So I'm wondering if you can tell us a bit about this take and how much you still believe that.
So I do believe subagents are still tools. And actually, I think a lot of things are tools. So recently I've been working with my team on something kind of in this specific problem, which is like, what is a tool? And is it really different than a subagent? And then you have things out there like deep research. What is deep research? Is deep research like an endpoint? Is it a model? Is it a tool? Is it a subagent? If it's a tool or a subagent, why is it not the other? And when you think about sort of like utilizing these things, like how do you want to communicate? Is it a skill? Is deep research a skill? Should you have a skill that calls deep research? How many steps of this sort of like research workflow should all be in one skill? Ultimately, I think all of this is like annoying semantics. But I think what is important is how do you block things in your brain? So, we kind of alluded earlier to the fact that like I am a category theorist, and so I will now be a category theorist, which is the only value in an abstraction is that it allows you to stop thinking about certain things. That is like the idea of category theory is how many things can I not think about when I'm thinking about them? So the reason I want to know what is a subagent and what is a tool and what is a skill is actually because I want to stop thinking about them. I don't want to. I need an abstraction because I want to stop thinking about the nitty gritties. we just had a long conversation about MCPs. I said MCPs. What I didn't say was, here is a set of tools that the agent can use to interact with Notion, and those tools have descriptions, and in particular, they also have some specific prompts that are associated to them. And in fact, all of the like authentication protocol is also stored in this little bag of information. And that whole thing that I just said, we abstract as an MCP. And yet, another example of an MCP is, here are 15 APIs that need to be called in a very specific order to get this information back so that my language model knows how to work with this particular kind of data in my organization that we fucking made up. Sorry, I swore again. We made this up. There's no way in hell the model's going to know what to do with it. I need to call it in a very specific ways with these specific API calls, but it's like kind of flexible, so I can't just wrap around one API. Here is an MCP that does all that. Those are like differently shaped things, but they're still both ultimately MCP. And so that's where the abstraction is useful. I say MCP, you say, oh, it's just a sort of like language wrapping around some like specific set of API calls and maybe how to execute them and some auth. It's the same idea. It's just
without
convenient.
A doubt.
And so when you ask me, what's a subagent and what's a tool? What's a subagent? A subagent is, you hand off a set of instructions. And when you hand off that set of instructions, you expect something to go and do whatever work is necessary to execute on those set of instructions. Those set of instructions are mostly natural language. And you may also hand off some sort of like authentication or some sort of like rights to authentication. What's a tool? A tool is a set of instructions that you hand off to execute something. That tool may have some authorization built in or baked in, but long story short, it is sort of, you expect a thing to execute. There's only one difference between those two things. There's only one. And the difference is how much intelligence is baked into the thing. So if you tell me, oh, well, the only difference between a tool and a subagent is that it also has a sort of like top level, like, decision-making language model, sort of, it gets to decide what to do. Okay, like, is that really like worth distinguishing? I don't really think it is. I think those are both tools. I think deep research is also a tool. Why? You hand off a set of natural language instructions and it has the opportunity to like execute on some specific goals that you kind of like give it ahead of time. Yeah, okay, maybe it does a web search for 15 minutes. Maybe it like writes 15 drafts and then goes through and like, marks it up and then does some more web searches. Who the fuck cares? Sorry, I swear a lot. Like,
hey, if you've done it once, we should do it all the time.
Yeah.
Well.
We've ripped the Band-Aid off. Well, let's go.
That's it.
So like, ultimately, I don't care. And in fact, I don't want to care. I don't want to really think if one thing is different than another. And so, at the risk of grinding my axe too much, this is why when people ask me like what language model libraries I like and frameworks I like, I don't like any of them, because almost all of them have extremely different interface patterns for all these different things. If you want to call a deep research, it's completely different than if you want to call a web search, which is completely different than if you want to call a tool, which is completely different than if you want a subagent. Why are these all so different? It is actually not very useful. And what you're doing is you're putting a ton of mental requirements on the sort of developer to presuppose a lot. And even more annoyingly, if you want to side-by-side things, because right now, the best deep research agent is not a deep research endpoint. Like, if you go to ChatGPT, their deep research model is not their best deep research agent. Those are two, like, they're different structures or different modalities. Why do they use different APIs? And so this is why it's not simply semantics to say like, well, actually, there's a very minor difference between these two instantiations. What it's really like, the reason I think about this is because I want to know how to make it simple for people to sort of utilize these things and to make it easy to move in and out.
I love it. And so don't get me started on different APIs as well, particularly with, recent deprecations of one Gemini API in favor of another. At least we're moving forward and moving onward. Also, historically, LLMs are horrible at knowing their own APIs, even when you tell them and give them the docs also. Yes. But what I do love that you're indexing on the practicalities of terms and abstractions. And I do think there are two things that have come to mind now. The first is I find the abstraction, the term subagent, useful in some ways, and not in a particular way. Useful because we're handing stuff off to things that are kind of like agents that are under the agent. And I find that useful. Also thinking about how we work with context engineering and handing off context and isolating context and that type of stuff. That seems to me that the term subagent helps me think about that. Now, where it doesn't help is authentication and permissions, right? Because anyone who has handed off things to Claude Code and Claude Code has handed it to subagents, and you walk away thinking it has the same permissions and go and have lunch and come back and no. And actually setting permissions well and carefully for subagents is non-trivial. So in that sense, subagents is a term which tricks me.
Question for you. I have a markdown file, and my agent that I'm working with has access to that markdown file. Inside the markdown file, it explains a way that it can call an API. The API behind it is a language model, and that language model is a research agent. It's really good at going and doing like research on the web and structuring its output in a very specific way. It always responds in a very structured way. Even if some of those like fields are empty, it's going to do its best to like put the stuff into the format, but it's never going to fail to respond to the right format. It does kick that back when you call that API. All of the sort of authorization and like the API keys that you need to call that other language model, they're baked in. The agent that we're talking to, it can just like directly call that from where it's at. All it has to do is run the code that is written in that markdown file. Is that markdown file a tool? A subagent? A skill? A deep researcher? Or something else altogether?
Well, I'll be a bit cheeky. If it's a markdown with some YAML front matter, I'd probably call it a skill, depending on... is it a skill if I haven't registered as a skill and I'm actually just asking my agent to read it, which I do occasionally, actually.
Great question.
Yeah.
Great question.
So, yeah, I mean, there are fuzzy, wuzzy, wiggly lines here, aren't there?
Mm-hmm. Mm-hmm. But ultimately, it doesn't matter.
Yeah.
Like, I don't care.
Yeah.
Again, the only abstractions that matter are ones that allow you to not think about things. So saying that this is a skill versus an MCP, that allows you to not think about things, where it's deployed. Yep. MCPs are servers. So like they need to be deployed. Okay, so we can say it's not an MCP. It's useful to say it's not an MCP. Is it useful to say it's not a tool? No. Is it useful to say it's not a subagent? No. Most of your subagents are not running locally anyway. So like who cares? Like there's no utility. And so that's where I'm like, I just push back on abstractions that don't actually like obfuscate any thinking from us or give us any sort of like leverage. There's no leverage. And so why make up another term?
Absolutely. So you mentioned frameworks, and I would like to chat on that. As you know, so your former colleague and my colleague and friend Stefan Krautchik at Salesforce teach a course, soft promo here on building AI applications, and the link's in the description. We have wonderful guest speakers. Bryan has actually come and spoken on retrieval, among other things, and I'll link to his wonderful talk, The Map is Not the Territory. Something we teach a lot of frameworks in the course of course, but we also really encourage people to start off with vanilla Python and API calls, particularly with a view to building out observability and transparency into their systems so they can inspect to see what's up. And the basic premise that we really take is you want to use frameworks that abstract over code you don't want to write and don't obfuscate things that you want to see. So I'm wondering in your hackathon and competition, What did you see in terms of people hand rolling stuff, using frameworks? What succeeded? What didn't?
I did see a little bit of framework stuff. There were some LangChain users there. I think that's pretty common. It's one of the most popular frameworks, and so it was unsurprising. I saw a couple folks like trying DSPy. I was particularly curious because the DSPy community is especially, I would say, braggadocio about how effective those methods are. None of them were especially like effective. I think part of the reason, in my opinion, was because DSPy seems to be successful at like marginal gains when you have a really reproducible like workflow. This is big, open-ended, and a lot of the tasks are quite unique. And so I think that's where like there's just like not as much value in that kind of thing. When you see sort of like a very high multiplicative factor or multiplicity in an individual task and shape, then you really get a lot of value out of something like a prompt optimizer. And there are some other ones that I think can be quite useful. We saw a little bit of stuff in like the ecosystem around like Solve It. So there was a team that did well that came from the Solve It crowd, but I think that was more for like exploratory stuff. But the number one thing that we saw that just like did well was kind of frameworkless. Just build what you need, Claude. Just go. And so because again, and there were some shortcomings of the evaluation, but because there were shortcomings of the evaluation, we saw people who took a maximalist submission approach performing the best. And that's where we saw really, really like, just very open-ended, just like, let's see how many shots on goal we can take. So
yeah, YOLO. Okay, great. We're gonna have to wrap up soon, Seth. I mean, you and I could probably just do a 4-hour live stream ourselves. Maybe we should. Yeah. Anyway, I do want to just think through people who are doing evals these days. Pardon me. We can think of evals some sort of ladder, right? You start off when you build something quick. You start doing something by vibes. Look at inputs, outputs. You're like, oh, these things aren't in the right whatever. This tone isn't what I want. Blah 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 blah. So you iterate quickly. Step 1 by vibes. Step 2, some sort of failure analysis where you're looking at different categories and pulling levers to see what you can do there. Rank ordering. And then you're starting to and building a gold data set, of course, through this failure analysis. Then step 3, perhaps starting to automate some evals. So for each failure mode or error mode, you have some script or some function that does some tests around this. Don't jump to LLM as a judge immediately, of course. A lot of things can be done via code base, code checks, all of these, testing for structured output, regular expressions, fuzzy matching, whatever it may be. So we have vibes, 1, vibes, 2, failure analysis, 3, eval harness, automating these things with some sort of golden set. I'm wondering what's next. And I do want to lead the witness slightly. There are many, and of course, failure is a final transition matrices for multi-hop agentic systems. A friend of yours who you introduced me to, Eddie Landesberg, is doing some wonderful work on causal inference for AI systems, and he's actually coming to give a guest talk in our course in March about how he's thinking about the next level of evals. But once we have this vibes, failure analysis, automating with code-based checks and LLM as a judge, where do we go from there? What are the next things you think people should be thinking about with respect to evaluation?
Okay, so the first thing I'll say is, at the moment, I'm teaching applied AI systems engineering. I'm teaching it at Rutgers, and this is a very, very like applied class. It's really, if you can think about sort of like, how would you take someone brand new to this area and coach them all the way up to being able to build like AI systems in production, like things that you would like ship to humans. And, it's a pretty like ambitious like scope, but we're really kind of like teaching everything. We're teaching everything from like the basic data science principles up to sort of like the most advanced like RAG systems and context engineering and shit like that. And so the first thing we did is we taught them evals. We taught them, here's how you think about evaluation. Here's why evaluation is important. One of the things that I got to do is I got to pretend like the totally normal thing in the industry is to like be really careful about evaluation and only build things after you've decided that evals are really important. I got to just pretend that. They don't know any better. They don't know that all these people are out there making huge mistakes. So I just got to sort of like say like, oh, this is like the way you do it, because it is the way you do it if you're successful. But I can kind of create this this magical world where everyone behaves. And so the reason I bring all this up is because with them, I teach them a framework. Similar to earlier, I talked about data framing and problem framing and objective framing. My version of that was for my DS class. My version of that for the AI class is sort of like promise, proof, and production. And so the promise is something that I borrow from the product management world. I've sort of like been the de facto product manager on a number of teams. And so I've sadly read some books on product management. And the number one thing that I've learned from that experience is, what are your jobs to be done? If you don't know what the jobs to be done are, you are doomed to fail. You cannot, I mean, you might as well just like roll a dice and to decide every feature if you don't know what the jobs to be done are. And it's not what you think the job to be done is, it's what you understand the user wants. And so I put a really, really, really big emphasis on this of like, you know, when you are doing X, you want to do Y so that you can achieve Z. And by setting it up, that story, that little like job to be done story, that gives you already an idea of what needs to happen. And so that's going to give you acceptance criteria. From the acceptance criteria, you're going to start putting together sort of like what you kind of need to achieve. Earlier, I talked about big checkpoints, and like, you know, these checkpoints give you a sense of like where you need to make sure that things are on the rail. How do you think you get to those? Those are acceptance criteria. So that's the first one. That's like the promise. Proof. What would you need to see to believe that this system is actually working like sufficiently well? And so you need to have some sort of hypotheses about like what is possible and what thresholds you could achieve. You need to have some hypotheses about where it might fail, and you need to run some experiments to see that if it actually clears those. And then finally, you spend some time putting this into production and building a system around it to make it reliable and like defensible. Okay, this may feel like a really, really long preamble to your question of like, what's next for evals? The reason I bring this up is because this is the way that I think about evals. I just think about evals as the proof stage. It is how you gain confidence and how you experiment to get to the point where there's worth anything, like worth doing anything. Okay, so what's next for evals, from my perspective, is a little bit less of this, like, I would say, obsession with like evals is this like special, unique practice, and much more of a blending with like the sort of integration between engineering and product. And to explain this, let me give you an example. If you think about sort of like traditional software, we eventually built unit tests. Unit tests are great. They give you a quick sense of like, does it work? And then from unit tests, we go a little bit deeper and we start building things like integration tests and smoke tests and stuff like that. Well, why do we build those? Well, what we want to know is like, okay, it like theoretically works, but like, does everything work together? Like, does it like actually do the things I expect? Okay, that's great. And then at a certain moment, we actually move on from integration tests and smoke tests and actually get into like click testing and QA. Well, why do we have those? Well, because actually there's things that like are very hard to anticipate, and they're much more in the family of like put a human intelligence on it to try to understand where it may be insufficient. And then from there, we actually still go on. We go into like A/B testing and like causal inference. And we start asking the question, like, does it have the effect that we're trying to like create? Does this software have the effect? And then from there, we actually go beyond that. After you've kind of worked through experimentation, especially like, like randomized controlled trials, we start getting into like data science, like analytics. We start asking higher level questions. Okay, things are happening. What's happening? What can we distill from that? And where do you go from there? Machine learning. And what is machine learning? Machine learning is all about, we've got lots of signal. We've actually got so much signal and so much noise that we can't really tell them apart. We're going to start building systems with an objective function. This big thing that we want in the future the world to be like. And we're going to let the machine converge towards that using whatever we can. And so if you ask me, like, what's the future of evals? We started out in the like old era of like shitty eval companies where they're like, we got A/B tests. Is that good? Okay, it's fine. Then we're like starting to get into the trace viewers. We got some eval companies that have like trace viewers. That's great. Now we're starting to get into the world of like, oh, you can like roll these out in like parallel and you can kind of see how they do and see customers' reactions to them and stuff like that. You can start to enable analytics and things that we care about. So I think the future is setting an objective function for your agent, setting an objective function for your system, and trying to allow your system to naturally converge there. I think that's where things are really going in like the eval space. And what I get excited about is continuous feedback from users that allow systems to converge to be better. And so that's my take.
Awesome. So I do want to wrap up by, we've talked about and really hinted at the third, but talked about two of the big lessons from your hackathon and competition. The first one is that many data problems are coding problems if you squint hard enough. The second was if you give people unlimited tries, they won't build trustworthy agents. The number one learning, though, was if you ask people to compete on a set of explicit evals, hill climbing won't move towards a useful agent. So I'm wondering if you could just tell us a bit more about this lesson. And then as part of this, what would you like to see builders do more of today?
Yeah. If I ask you, you go, will you cook me dinner? And you're like, I guess. And so you cook me dinner and you bring it to me and I say, this sucks. Do it again. Now, the likelihood that you'll be willing to do it again is low, but let's play the game for a second. Let's assume that you're really on board for whatever reason and you make it again. And I say, this sucks too. And you make it again and so on and so on and so on. There is no chance that like you're going to converge on me being happy. But if you bring me this first dinner and I say, oh man, I actually I really don't like mustard. And like, even though I love Cubanos, like there's too much mustard on this for me. And then you go back and you make another Cubano that doesn't have mustard. We've very rapidly converged to a delicious meal for me. I had to pick mustard because it's like the only thing I dislike in food. So I think good feedback is so essential in everything. And unfortunately, I didn't give people good feedback. I only gave them binaries of this is wrong. And because they had no incentive to give their agents feedback, there was no reason for them to actually hill climb. So,
but I just want to remind you as well, and I don't need to remind you this, of course, but you wanted to automate all of this. And so it's an open question, should we be automating all feedback currently?
Right. And I think your point there is, well, you can't give great, rich feedback if it's automated. That's mostly true. But think about the pivot. If I had just pivoted to wrong answers, subtract a point, what would have happened? Or subtract a tenth of a point. What I would have done is I would have pivoted the feedback problem to the contestant. The contestant would have had to give feedback to their agent. And so because I was giving no feedback, okay, there was no feedback yet, but the contestant could have been giving feedback, but they weren't either because they had no incentive to.
Makes absolute sense. So, to that end, what would you like to see builders do more of today, and how?
I think everyone that's working with AI should be asking how clearly they can take their goal and put it into acceptance criteria. The better that you can do this, the more good that you get this, and the more that you can encode those as acceptance criteria in a way that is like easily checkable, the more successful you will be. Now there's things like reward hacking and like, there's a few like, nuances here, but you will be a better vibe coder. You will be a better AI builder. And candidly, you will even be just a better product builder if you are exceptional at building acceptance criteria.
Awesome. So, Bryan, I am putting in the show notes and in Discord links to your Twitter, the platform formerly known as Twitter, your LinkedIn, and Theory Ventures. It's Dr. Donut, aka Dr. Donut on the Twitter. We need to remember David Lynch's maxim, focus on the donut, not the hole. Is there anything else where people can follow you or keep up to date with your work as well?
Yeah, those are the usual channels. And I would say, like I'm doing about a monthly podcast these days with some really amazing AI founders. And so that's released through like the Theory website and our blog. And so if you want to follow that, it's called In Practice. And so I'm getting to sit down with a lot of really, really amazing AI founders. We're launching one this week with Chung from LanceDB. And so we have a really, really fun conversation about sort of why multimodal data is so important. You heard a little bit why multimodal data is even important in this sort of like data world. So there's that fun thing. And then I haven't announced it anywhere yet, but I am going to be releasing my AI systems engineering class online. And so there will be videos and there are guest lecturers who I think are pretty exciting. And so to give you a little taste, first guest lecturer was Hamid Hussein, who everyone on this viewership knows well. And the second one was John Berryman. And so definitely...
Awesome. Well, people know John. I had John and Doug actually on the podcast recently to talk all about agentic search.
Amazing. Yeah. So we have some really great guest speakers and we have some really great content. So if you're someone who feels like what would be valuable to you is sort of seeing start to finish, like the AI engineering curriculum, I think this will be the best resource. I don't know currently of any resource that I think is really useful and comprehensive for the whole AI engineering stack. And so that's the goal. It's going to be a point in time because shit changes fast, as everyone knows, but we'll do our best.
Awesome. Well, super excited for that. Thank you everyone for joining. Please do like and subscribe, share with a friend, follow our Substack, check out what else is happening on our Luma calendar. A lot of fun stuff coming up. Most of all, thanks, Bryan, for your time, wisdom, and just good vibes. I mean, I always enjoy chatting with you, and clearly we could riff for a lot longer, but we'll save that for another time. So thanks, man.
Awesome. Thanks a lot.
And